All right, so we are going to talk about vertical angles today. The first thing we need to understand before we get to vertical angles are opposite rays. So when I discuss opposite rays, I need you to understand what those are. So for example, AB is an opposite ray with AC. Notice they have the same intersection point, point A, and they are making a 180-degree straight angle. They are going in the complete opposite direction. Okay, one's going west, one is going east. Those are opposite rays. Another example down below is ED. Okay, that is an opposite ray with EF. Okay, complete opposite rays. EG is also a complete opposite ray with EH. They're 180-degree angles. If you look at them, they're going in the complete opposite direction. So the definition is two collinear rays that have a common endpoint and extend in different directions. Okay, those are called opposite rays. If you look over here, an example of something that is not opposite rays look like this. Okay, JK and M are not part of the same line, so they're not opposite rays. PT and RS are another example. Those are not opposite rays because they do not have the same endpoint. Okay, an example of opposite rays would be PT is opposite with PS or PR. Those are opposite rays because PT goes this way and PR or PS goes that way, and they share point P. They create a 180-degree angle. So that's what we're talking about with opposite rays. In order to understand vertical angles, you need opposite rays. So vertical angles are formed from opposite rays, okay? Two angles are vertical if the rays forming the sides of one and the rays forming the sides of other are the opposite rays. This is what it means. Angle 1 is formed by this purple and blue ray. Okay, angle 1 is formed by the purple and blue ray. If I were to trace the opposite of the purple, this is the opposite ray of the purple, and if I were to trace the opposite of the blue, this is what I get. Okay, so here's my blue right here, and here's my purple right here. You guys can see the opposite. Sandwiched in between the blue and the purple are angle 1 and angle 3. Okay, we call angle 1 is vertical to angle 3. Right now, angle 2 is vertical to this question mark angle. There's no name to it right now. But 2 and the question mark, angle 2, is vertical to the question mark angle. Okay? Now let me draw you another example. Hang on, because this, I feel like a lot of students will always confuse this. So let's say I have this written down right here. These crooked lines are really throwing me off. Pretend this is all coming from this point. So angle 1, 2, 3, 4, and 5. Okay? An example of vertical angles would be angle 2 and angle 5. Those are the only two pairs of vertical angles. Okay? Angle 1, right here, angle 1 is being formed by this line and this line. So angle 1 is vertical with this angle right here, this whole angle. Okay, and 1 is not vertical to 3, 1 is not vertical to 4, 1 is vertical to 3 and 4 together. Okay, so over here I have if 1 and 2 equal 180 and 3 and 2 equal 180, then what has to be true is that angle 1 has to be equal to angle 3. Okay, that's kind of like the opposite of the substitution property. And this brings me to theorem 18 right here. If two angles are vertical, they are equal. They are congruent. So if angle 1 is 50 degrees, you know angle 3 is also 50 degrees. Okay, vertical angles are congruent. So we're going to go over some proofs and what this would look like using vertical angles. So we know how to define vertical angles. So far my given information is that angle 2 is equal to angle 3, given. When I see a problem like this and I get stuck, I take a look at what I'm trying to prove. I'm trying to prove something about angle 1 and angle 3. And so far in my proof, I have nothing written about angle 1. So I'm going to look at my diagram and see, is there anything I know about angle 1? Oh, well, this entire section's on vertical angles. So I'm going to look at angle 1, and I see that angle 1 is vertical with angle 2. You do not have to state that they're vertical. You can jump immediately to angle 1 being congruent to angle 2. And the reason you know that is because if two angles are vertical, then they are congruent. Okay, if two angles are vertical, then they are congruent. Oh, look, I have angle 3 equal to angle 2, and I have angle 1 equal to angle 2. That means that angle 1 has to equal angle 3, okay? If my grade is the same as Steve, and Steve's grade is the same as Bob, then obviously my grade equals Bob. That's the transitive property. If two angles are congruent to the same angle, right here, okay, that's the same angle. If two angles are congruent to the same angle, then they are congruent to each other. That is the transitive property working right there. Okay, so first we use vertical angles, then we use the transitive property. Another example of a proof. So again, statement, reasons. Step 1, angle O is comp to angle 2, given. I see lots of angles being used, so I'm going to start coloring mine. So angle O, which is this angle right here, is complementary to angle 2. Angle J, right here, is complementary to angle 1, which is right there. And I'm going to be writing that down, so that's why I'm filling this out. Angle J is comp to angle 1, given. Okay, so I filled in my given information. My little OCD, I have to color this up here. So what do I know? Let's take a look. So O is complementary to 2. They're not next to each other, so it's not forming any kind of right angle or perpendicular segments here. Oh, this entire section is about vertical angles. So I have angle 1, which is being formed by HM, vertical with angle 2 because they're both being formed by a pair of opposite rays. Again, I don't have to state they're vertical. I can just jump to angle 1 is congruent to angle 2. And again, I'm going to say if two angles are vertical, then they are congruent. Okay, if two angles are vertical, then they are congruent. That means that if the pink and the green are equal, okay, so take a look right here. If these two are equal to each other, then that means that these two have to be equal to each other. So that's what I'm going to jump to in step 4, and lucky for me, that's what I'm trying to prove. So angle O is congruent to angle J. My reason would be if two angles are complementary to congruent angles, then they are congruent to each other. Okay, if two angles are complementary to congruent angles, then they are congruent to each other. Okay, so again, using vertical angles and then complementary. Here, using vertical angles and then transitive property. Just understanding what vertical angles are